So, couple things real quick before we start. We're checking the homework, and people had questions on number 83, and we are looking at homework 4.5.2? 4.5. Okay. For this, what I asked you guys at the start was, would this help? And if it doesn't, awesome, don't write it. If it does, awesome, write it. I know that these functions have all the following pieces. D plus A times the sine, since we're talking about sine, of bx minus c. And it drives me crazy. Their book does a d plus. I do plus d on the end. I don't know. So whatever. Okay, so let's look. Anywhere in here, did we get enough, or do we get information that tells us what d has done? What does d change in my graph? Up or down? Did we go up or down? We went up 1, so what's d? 1. So we already have that locked in. Let's just keep kicking. A is for amplitude. Do I know the amplitude of this graph? Dose. 2. We got it. It's right here. They state that. Okay. These pieces get a little bit harder. The phase shift. I don't love that language. Now, it's a real formal language, but when I think of the phase shift, what's it actually asking? The starting point. Like, it's the same idea. Now, we have a couple ways to get through. I know what the period is, and I know what the phase shift is, which I'll write phase here, but it's just that bx minus c idea. Phase or start. Okay. They tell me the period of this function. I'm going to pretend like they haven't yet. If I wanted the period of any given function, how do I find it if it's sine or cosine of some graph? 2 pi something over b. This is how we get the period, right? And what is the period of our graph? Pi. If only we had an equation that had one unknown and the only unknown was b. Oh, what's b? 2. Multiply by b, divide by pi, we get b is 2. Just in case that one didn't click, what I just said is if we solve this equation, multiply by b, and I'll do little steps. 2 pi then is equal to pi b, which is weird that I say 2 pi and then pi b instead of b pi, but it feels more natural to me, and I don't know why. All right, then to solve for b, what do we do? Indeed, and we get b is 2. Like, that's where it came from, just in case it was too fast. And then here, we are going to get what? So not what are we going to get? Like, I agree with you. So first of all, that's right. Let me ask the question better. We know A, B, and D. Is this going to allow me to get C? So I know that to find the starting point, or how far we've shifted our phase of our graph, left or right, is, how do we find it? It's dictated by something. So there's a couple different ways. You said 0. What do we set equal to 0? Now, I'm going to do one more step further than you guys did, but this is what we normally do, right? Yesterday in class, I believe we did it, but I didn't make it like a whole, hey, everybody notice this type of situation. I can solve this in general and always do it, right? The x value, no matter what, is going to be c over b. Do you agree with that? Now, we have phase shifted to the right or left? To the right. So I know that c over b, whatever it is, the first value that we plug in is going to be what? Or the first value of our function, the first argument. And there's a weird one. How do I want to phrase this? How do I want to word? I can word that better. I'm going to see if you guys can word it better before I do as I'm thinking about it, so you don't just have to sit here and watch me think. How can we use what's written on the board down here? Not so much this part. And the fact that I've been phase shifted to the right by pi halves, how can we make those two agree with one another? So I'm essentially asking just how do we set this up? Not what is the answer, but how do we make this connect back? Did you get this number for it? Is that what you got for it?
For me? I got over 2. Oh, no, I switched it to 2.
I'm sorry, how about, so for C, we're not quite sure yet, right? So if we look at this, if we look at a graph, if you go to 1 from yesterday.
Are you asking if it's negative or positive?
So I mean, I know what it's gonna have to be. I know it has to be negative. You know it has to be negative? Okay. So we looked, I'm trying to see where we did this. The phase shift is the same as my new start value. So I'm gonna plug in what, like, where do we start? Sorry. And I might have to actually look at it. Instead of starting at 0 for my first x, it's been shifted how far to the right?
It's working.
I think so. I know B. Can I see if I know B?
Oh, yeah, so they're working.
Okay, check it out. And I don't know why this is so awkward for me to try to word the first time. This is my starting value. Do we all agree with that? Now, if I, instead of starting at 0 for x, I start at pi halves, and it's a phase shift of which direction?
Right.
So if I'm at 0 and I go to the right pi halves, am I at positive or negative pi halves? So if I'm at 0 and I go to the right, am I at pi halves or am I at negative pi halves? Okay, I agree, we're at positive, and it's easy to see it once I write it, so that's my bad. So what's this value going to be, our first start? It's going to be pi halves. Now, here's where we get a little wonky. I have 2 unknowns. Is that true? Not really. Why isn't it true, Wisha? Hey, b is 2. So if I use that, I think I get c over 2 equals pi over 2. And without doing anything, I can tell you what c is. Pi. C is pi. Therefore, c equals pi. I know A, B, C, and D. Let's just put them all together. And I am going to do this. I'm going to switch it to over here because it's bugging me since I've written it. So let's just see if we get the same thing. F of x is, what's A? 2 times the sine of what's B? 2x minus what's C? Pi plus, how much did we move up? This is what I think it is. And I feel pretty confident about it, but I won't feel real great about it until we see that this is it. You guys ready to cheer or what? We got it. Cool. They're tricky the first time. Did anybody get that answer before I did it? Good. I'll tell you, I do think that everybody in here could get it. Like, I'm fully confident that everybody in here has the skills and tools needed to do it. If it was a time issue because you guys hold by what I tell you, good. If it was, you looked at it and said, I don't know what to do and I didn't try anything, I would encourage, try not to do that. Cool. Be valorous. Yeah. For real. All right. That was all of them. How'd it go? Went pretty well? How many assignments? Have I collected much from you this week? I'll take it. I don't want to, but I will. I will have your quizzes graded by tomorrow. Sorry, I'm running behind on it. But I do have some team tests to give today, which makes free time for me. Team test for a student class. You got me good. You got me. I did that to Zeke this morning when I sent him his breakfast. He did not find it funny. Oh. Thank you. Yeah. All right. So, you know what's cooler than graphing sines and cosines?
No.
All the other trig functions.
Before we start, can I ask, what's the context of the glib glabs happily?
Oh, that's easy. It's my business.
Okay.
No. So, Red understood it was a joke. Everybody else. Anyway, rise and shine, everybody. We are doing some more trig graphs. They're not going to understand that there was a nice little interlude between those statements, but you guys do. All right. So, sines and cosines, pieces of cake. Let's jump in. We are looking at 4.6 graphing. And realistically, depending on how hardcore we make our table, graphing versus sketching, we've talked about. Do you guys remember the difference between those two? What takes more time, to graph a function or to sketch a function? Graph. Sketching, we just need the general ideas. If you're actually graphing, we would commit more time. And they're almost synonyms. But we're going to graph. Graphing of what? Anybody write graphing of and think, how on earth is he going to make this work? Because it's supposed to be other. Yeah, the glib glabbed. Graphing other trig functions. All right, so we have done sine and cosine. What are some of the others? Tangent, cotangents, secants, cosecants. Where do you want to start? Tangent? Sure. Let's look at tangent. So we'll have like bullet points. We'll do tangents here, and then we'll do cotangents, and then cosecants and secants. Not all today, I don't think. So let's consider tangent and cotangent. Okay, for these, if you don't have a unit circle in front of you, I would advise it because it will help. So here we go. Our first, let's consider the graphs made by y equals a times the tangent of bx minus c plus d. So we're just going to jump in and say, hey, there's this form as well. And we're going to start with the nicest of these and just try to save a little bit of time with not having to be redundant. If I wanted the nicest possible function that every other tangent function comes from, we would say we have the what function? The parent function. So for starting in here, we're going to do that. We're just going to say the parent, and I know what it is, but I'm going to make us break it down a little bit nicer. We'll see. If I want this to be the nicest possible function, the parent function, I'm going to give you guys like 40 seconds because there's 4 things that I want you to tell me. If I were to plug this into Desmos with sliders, which just means I can change A and B, like those, they slide the values, what would I set A and B and C and D to be the parent? I want you to tell me if this is the parent, and we're going to write the parent here in a second, but what would we need for A and B and C and D? Now I'm going to give you guys, I said 40 seconds, but we'll go a solid 60 since I don't have a 40-second hour class or minute class. 60 seconds from now, we're going to discuss it as a class, so you guys discuss it together.
Oh, okay, now I get it. C is 0. And D is 0. Oh, yeah. I forgot it. So we told that A.
I'm going to call you for B because that makes sense. Because you're right, just, you know, yeah. All right, so let's see here. I really wish Addison were here because this is going to work much better if she were. All right, A is for Krina. What's A? I just destroyed my C, but if I want this to be the nicest possible version, what's A? 1. Good. Anybody second that? Good. B is for Basil. What would you like B to be? 1. Perfect. C is for Christina. What do you think C's must be 0? And D is definitely for Redmond. God, what am I doing? Dolan. Just kidding. It's red still. 0. Okay. Really missed an opportunity there. If we were to set A as 1 and B as 1 and C as 0 and D as 0, we have the simplest possible function. What is the simplest possible function? Y equals the tangent of x. Now we call it y or f of x or g of theta. It doesn't matter. I, for no reason, picked y. So now that we're here, we're going to go back to our unit circles. I said to you guys before the quiz the other day that you can put the tangents on your unit circles. Follow up, have you?
No. Yes.
If you haven't, you should do so. Let's use those real quick. When we started thinking about sine and cosine, I had to go all the way around the full circle until I got to the same point, right? So like I know that I hit all the values between up to 1 and back down. I hit them twice throughout a period. I want you, looking at the unit circle, to see how far in a rotation do you think we have to go until we start getting the exact same values repeating for tangent. So I'm really asking you to help me find the what of tangent. The smallest amount before it'll just repeat itself. The period. Now, there's some other pieces that we can think about with it that might help, but I want you guys first, on the unit circle, can we reason out just if you have the tangents listed? And Matilda, I'm going to hook some others up. Can I use yours real quick? Okay, in case you don't have the tangents. Did you get me or did I get me?
No, you
okay, this guy. All right, so fingers crossed Matilda's right. I did not check.
Oh.
Okay, so up on the board, Matilda has said that this is root 3 over 3. Because she did sine over cosine is 1/2 over this. I'm comfortable with it. Here are our tangents. They're on the outside. That's a 1. Cool.
Don't mind my handwriting.
No, I do mind it. The nice thing about this is that we get the same repeat. Now the fractions aren't quite as nice. Root 3 over 3, 1, root 3. Root 3, 1, root 3 over 3. We get that same pattern happening. So if we know quadrant 1, we should be able to get the rest of them because we get that symmetry. Now, if we start looking at this, and this is going to be weird, but there's a more natural place to start than this. But let's check. If I start here, I go root 3, 1, and root 3. And I'm going to try to graph a little bit of this as we're going. And I'll take a picture and just put this up on there. That's the better way to go. Do you understand what I'm asking before I talk all the way through it? Let me try the question again because I probably lost you. Is there a smallest amount of rotation where we get all the repeats to start happening, like we did with sine and cosine? And it might not be readily evident here, but rather than just telling you what the period is, I think we can figure it out, and we are going to figure it out. So here we are. How far around the circle do I have to go before I don't get new values showing up? Pi halves. So what do you mean by that? Now, what I'm going to do, and we're not making our table here, not truly anyway, and I don't want you to have this table, but I do think we can probably reason this out. Okay, if I started making my graph, and I'm not going to truly make the table, and you guys can hold off if you want, but I just want to plot some points. At 0, and I'm just going to eyeball here, I have a calculator. Anybody know the square root of 3? You get 4 seconds to give me your best guess. My guess is 1.6. I have no idea what it is. Probably about 1.6. You know, I'm actually really short, I think. 1.7. Gosh, I'm way off. All right. You can't see it. I didn't do it in my head, just so you know. I did this. Cool. So, if we're looking, and I only did that so I could put this on the axis relatively easily. At 0, what's the tangent? There's nothing written here. Is it 0? Are you sure?
Wait, what is written there?
Oh, it is written there. Gosh dang it. I was trying to get you. It's 0. Okay. Give me another point that you see that's nice. And it's not going to be nice. 1. Where do you see 1? At pi fourths? So here's pi fourths. And you go up to 1. Deal? And if I went to negative pi fourths, I would be at what? Negative 1. So they'll be all the way down here. And these aren't going to be nice. I'm just going to approximate them. Let's get another point. What if instead I went to, I don't know, a little bit more at pi thirds? Is root 3 over 2 bigger than 1? So it goes up a little bit more. And then it goes down a little bit more over here. Have I lost you? Okay, give me another one. Up here, what is it? It's undefined? Why?
What are those lines called again that you can't touch?
It has 2 syllables, but you might think of it with 3. My student teacher. That's.
Oh yeah, there you go.
There's an asymptote. Yep. So, gosh, when I get all the way over to pi halves, which would be right here, am I ever going to touch it? No, so I heard asymptote come out. I'm so angry right now about it, but that's okay. So here it is. Where's another asymptote going to exist? There's going to be one over here as well, right? Now, if I wanted to go a little bit further, and I just want to see what happens, and again, we're going to build a graph together as well. I just want to see if we can logic it out. For this, if I got a little bit closer to pi halves, so like right here, as long as we think about it, the ratio of y over x. When I moved from here to here, did y get bigger? Did I go higher up from this point to this point? And if anybody's zoning out, or because I was pointing at the board, when I moved from pi thirds up to here, it got bigger y value. Did the x get bigger or smaller as I get really close to this? So I get a bigger top of my fraction and a smaller bottom. That number just keeps getting bigger and bigger and bigger and bigger and bigger, right? So it seems to agree with this asymptote behavior where, what's it going to do? It never touches and it just keeps screaming upward. Then on this side, it does the same thing but this direction. What if we went a little further? Like, I don't know, slightly bigger than pi halves. And we'll do this nice value. So at 3 pi fourths, which would be right here, what's the value of tangent? At 3 pi fourths. -1. So now it's here. And if I kept going, what we're inevitably going to see, and I'm just going to start graphing on this, is I would go to pi and I'd get 0 again. And I'd go to 5 pi fourths and I get +1. And then we run into another asymptote over here. And all of a sudden I can see that, gosh, those certainly look like the same picture to me, like it's just been picked up and moved. Would you agree with that? Now, from this, what we have really and truly just graphed is the parent function. Just so you're aware, we just did it in a way that I've never done it before. Does it seem reasonable the way we just did it? I like doing it this way rather than just giving us all the stuff. So now here's the fun questions. And we're going to put all this together. I will wind up erasing like all of this. Matilda, did I give you back your unit circle? I did. Okay. So my question for you right off the bat is for the tangent function, the parent function, the simplest, what's the period? What's the smallest interval that I pick it up and I put it back down? And not only how big is the period, but from where does it run to and from is my big question. Love it. Do the second part now. From where to where? Okay, so I've heard the answer from at least one group. On the count of 3, we're all going to say what we think the period was. 1, 2, 3. Pi. Good. Okay. If you didn't think pi, would you be willing to explain what you answered? What did you think? What did you think it was? So pi halves. And I like that idea and I can see it. Do you know why we said pi? If I were to pick up the biggest or the smallest piece that I could where it just copies over, do you agree that it's going to be this section of it? And how much distance do we travel on the x-axis for that region? Notice I'm not quite touching the asymptote, but I'm really close. From negative pi halves to where? And that's how far? That's pi. So this is my piece, right? If I look at this, and this isn't going to work the way I want it to, I don't think, but we'll see. There's my second period and the third period, and I can start seeing it. It is the period. It has a length of pi. Now, what I want to do with everything, oh no, I can't just control Z anymore, is I want to see if we can't make sense of this and get some super duper nice values. Good call, by the way, whoever suggested to pick pi fourths. That's the nicest value that there is. So here we go. Just now, we discovered a few really important ideas, and we're going to build the parent function again together in a more structured way, but I like that I didn't have to answer any of it for you. For the tangent function, what was the length of the period? Pi. Now, how is this different than sine and cosine? It was 2 pi before, right? So we have pi. The jump that we would look at, and we'll do that here in a second. Were there any other interesting things that might be worth noting from the graph that we had? And I'll put the really rough graph back up. And I hope that we can come to an agreement here. But here's a graph that we had, almost. Here's a graph that we almost. Why would I change it? I could just say the scale is different. Whatever. Okay, there's a graph that we had. Anything else that you think might be worth mentioning as we're talking about like the key features of this? The period is pi. I'm good with that. Asymptotes, where do the asymptotes exist? And I'm going to say VA instead. Now, for this, the vertical asymptotes. I have one at negative pi halves. I have one at pi halves. Without going through the whole process, can you tell me where the next one's going to be? So let me rephrase. How far do we have to go to get a full period of tangent again? So if I went pi more, I'd be at pi halves plus 2 pi halves, because that's pi. I think it's 3 pi halves, right? So, and then could I just go another pi and I'd be at another asymptote? And could I do it again? So we're going to make this a very mathy statement. We're going to say that these graphs for tangent, every time they do have vertical asymptotes. And they will always occur at the following place. Now I could start, it doesn't really matter. I'm going to start at pi halves. But I think that my vertical asymptote, or asymptotes if you will start at pi halves. And then I can add on any additional number of how many radians? Pi. So I don't just want to say plus pi though. What if I wanted any possible number? Like could be 1 pi, could be 2 pi and 3 pi and 4 pi. So if I go 1 pi, I wind up here, right? If I'd gone instead of just 1 pi, 2 pi, do I wind up at another asymptote? Will it work for 3 pi? Negative 7 pi? If only there were a way to say, hey, it works for any change that's a multiple of this. N pi is a pretty standard way to do it. And then here's our rigor coming in. This is as long as n is what sort of number? 1, 2, -1, -2, 7. What sort of numbers are those? They're integers. Gosh dang it. Well, here we are. What's the integers? What's the symbol for the integers, rather? Z. Blackboard Z, but Z nonetheless. Now, again, you do not have to write what I say, and for anybody who watches the video or doesn't really watch it, you just write down the notes. It's okay, but you lose a lot of stuff. If you hear me say that this is the integers and you'd rather say n is integer, good, do it. I'm fine with that. I'd like you to start getting used to this notation stuff, but they're the same thing. Okay, any other important things that we might want to include on here? Where do we start? Like if we wanted to, like I could start here, and that'd be weird though. Does everybody agree this is the most natural place to start? Seemingly. So this is where it gets wonky. If we're looking at our start value, like we did with the other one, we know it's going to somehow tie into this, bx minus c, at least in a little while. What's the furthest left that you would start with our first period? I'm going to go back to blue. And it's a weird question. I wouldn't say we really start there, but we start as close as we want to there. If I get really close to it, but I don't quite touch it, what am I trying not to say? It's an asymptote. Where's the left starting asymptote at? So I'm going to say this when the argument, and in this case it's just x, right? Because we're just doing the parent. But we're going to say it's when the argument is equal to what? I don't like pi halves, not quite. I'd like negative pi halves. Now, what winds up happening on our tables, and this is really going to be a nice thing, is our table is going to start with an undefined and it's going to end with an undefined, because we're going to start here at negative pi halves, and where are we going to end? It's when the argument is equal to positive pi halves. Now, just to make sure so we can see it, these will both be undefined. Undefined for table, or on table, whichever one makes more sense in your head. Now, amplitude certainly does apply here, but it doesn't feel like it means the same thing. The amplitude of a wave is half the distance from crest to trough. Why don't we use amplitude necessarily to talk about tangent? Can you point out the crest of this wave? No, because it's not a wave. Right? Like it does something completely different. It doesn't make sense to talk about the crest and trough. You can think about it as the steepness, if you'd like, the orientation and shape. I'm not going to write it here because I don't want to call it the amplitude. But if I have a tangent, compared to a 5 tangent, which one do you think is 5 times steeper than the other? 5 tangent. So I'm trying to think if I really want to do that. Do you guys agree that this is a same sort of graph, but significantly steeper? The red one I just drew? So steepness, it's a weird idea, but just like a quadratic, we could say it gets thinner, but it doesn't really because it still gets to the asymptotes steeper. Okay. Anything else worth jotting down? Oh my, domain and range. Excellent. What is the domain of this tangent function? It's the set, and we're going to do it in interval note, or sorry, set builder. The set of x something. Remember, domain questions, we're always worried about breaking our functions. Does it make me divide by 0? Does it make me take the log of a non-positive? Does it make me take a negative square root? Things like that. Tangent is a division problem. Because how do we define tangent? Y over x, or give me an alternative. Sine over cosine. Now, with that in mind, I can't let cosine ever be what? So anywhere that cosine's not 0 is fair game. Where's the first place that x value, or the first angle that would make cosine 0? So look at your unit circle. Where's the first place that cosine is 0? Pi halves. Where's the second place that cosine is 0? Where's the third place? So I would say pi halves. Oh, you went the other direction. That's okay. Pi halves is here. And then I'm going to keep going the right direction because I'm backward. Is this the right direction? So now we're at 3 pi halves, 5 pi halves, 7 pi halves, 9. And we just keep getting these pi halves, right? Every time I'm just going a half circle away. Do you agree with that? And how much is a half circle? So pi halves won't work, but neither will any multiple of n pi. And what's really cool about this, and I think it's cool, I think it's neat, rather. Are the domain and vertical asymptote questions really any different? No, if you can find the vertical asymptotes, you have also found your domain. It's just a matter of how do we actually write it down. And last but not least, what about the range? All reals. So we'll say it's a set of y's in this case, such that, how would I say all reals? So you can say just the real if you want to. I'm going to be a little bit more formal. Y is in the R, and I'm cool with this. If you just write R, the Blackboard R, I will give you credit, just so you know. Okay. Now, with this, we have everything that we need to be able to graph these. We should build the table for just tangent itself. And then tonight, like we'll have time to do that, then I want you guys to do something very similar to what we were doing yesterday. But we're just going to do little tiny tweaks with it. But let's dig in. So we're going to build the table for tangent and like the actual parent function. And I know we graphed it, just reasoned it out and said this is what it should look like, and we did that. But let's actually build the table using this information. So let's try it out. Now, I can do a 2-column table or I can do a 3-column. I don't care. Do you? Okay, so if you want to do a 2, I'm good with it. Somebody wants a 3, I'm good with it. So we have x. If you only want 2, just use 2. Tangent of x and the y value. Now, I have taken everything away from this other side, and there's a few more pieces that are so convenient to use that we will use. If I look at only the information that I can currently see on the board, where would you like me to start? When the argument is equal to what? Negative pi halves. Now, the argument in this case is x, so those are one and the same. If my argument had been like 2x, I would have to do a little bit of scratch work and say, when is 2x equal to negative pi halves? But we don't have to do that because this is the parent function. Here's where we start. Now, we won't do a ton of these, but I'm going to say the tangent of negative pi halves. And when we try to do this, I have negative 1, because that's a sine, over 0. Negative 1 over 0. And this should give you some anxiety. It's undefined. And it really shouldn't give you anxiety. That was me trying to be funny, but it obviously didn't work. Okay, undefined. Cool. What's the next nice value? Now, here's, and I wish I could be on camera right now. I'm going to draw up here, but it's only because I can't just use hand motions, okay? You do not need to draw this. I'll make it big and obnoxious and pink. If we are only going negative pi halves to pi halves, if I wanted to put my first starting point at negative pi halves, where do I go? Here I am at standard position. Which direction do I move? And you can't just say up or down because that doesn't make sense on a circle. How would you have me work from here to negative pi halves? So I don't know how I expect you guys to answer this. I know what I want. Clockwise, says Dolan. Okay, so and I clockwise till I get here, right? And then I'm okay with my function. I start here, it's undefined, whatever. And I'm good, 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 and then I'm undefined again, right? Which half of the circle are we working with tangent? Say it again. Quadrant 1 and 4. So if I just said which half of the circle, how would you describe it? Is it the right half, the top half, the left half, or the bottom half? And have I lost people with that idea? Okay. Is everybody comfortable with going from negative pi halves to pi halves?
Yeah.
And I work in a positive direction because that's how the number line works. Do you agree that right now, on an angle perspective, if I start here and end here, I'm at negative pi halves? And then I work which direction if I'm going positive? And I keep working until I get to which next value? Right here, right? So I can go this much of the circle. Which part or half of the circle did we just highlight? Is it the right half of the circle? Is it the top half, the left half, or the bottom half? So you say top half red, and I'm okay with that. I don't agree with it, but I'm okay with it. If I said, here's a circle on the board, I think that this is the top half. Would you agree? And it's not very circular, but this is the which half of a circle? The left half. This is the, and what we just drew here is the what half? We're using the right half of our unit circle. Now, I'm using that because I know that in the next section, we're going to talk about inverse stuff, and we're going to reference that, so I want you to have it. But we are on the right half of our unit circle. If we're only looking at the right half of the unit circle, where's the next nice value that tangent shows up? Say that again. So that's the next value. I agree. Matilda said -1 just now, but let me rephrase the question to make sure it comes out very clear. What's the next radian measure? So I don't think it's 7/4. And this is weird, but here's why. If I said, take me from here, Matilda, and everybody for that record, if I said, take me to 7/4, which way are we going to go? You're going to go here, and you're going to wind up here, right? But I don't want to use the left half of the circle at all. I just want to end up here without using the left half. Where am I? I'm at -pi4. Now, there's something awesome that we're going to reason out of this. At -pi4, if I don't do the middle column, and you don't have to, but what is the tangent at -pi4, where sine and cosine are equal, but one is positive and one is negative? So it's negative, so it's √2/2 over -√2/2. And I'm not going to do any more middle column, just so you guys are aware. But it's -1. Okay, so we're still on the right half of the circle. We're working in the positive or counterclockwise direction. I started straight down and it was undefined. And then I just start working counterclockwise to get the right half of this unit circle. I got to here and I said, oh, that's really nice. Where's the next nice value? 0. Is it nice at 0? At 0, what is it? 0. Tangent is 0. Now, I'm going to pause here because we could logically get to this answer if I just said, now let's keep going, but I want to hold off here. Is tangent even or odd? Tangent is odd, which means if I were to do f of -x, it is the same thing as the opposite of whatever f of x is. That's what it means to be odd. What's the next value that I'm going to put here? I'm sure of it. pi4. Now, without me ever thinking about the unit circle, and I'm not trying to, I'm only going to use this and pretend like I don't know the unit circle. Is this like I'm doing f of -pi4? That's what this is, right? And if I know that it's the same as the negative f of pi4, what's the tangent of pi4? Or that, it's 1, and we have it, right? Now, alternatively, I know that there's symmetry that's odd, and it crosses, or it's symmetry about the origin. It's symmetric. If it went down 1 on this side, it's going to guaranteed go up 1 on this side. I can use the even and oddness here. Last little piece, I need 1 more point, and it feels kind of redundant sometimes to put them. What's the last value I'm going to put on my table, though? Pi halves. And it's going to give me a undefined. Now, we can graph this, and I don't intend to give you homework tonight looking at the time. I didn't look at the clock until it was already like 15 after, and I don't know what happened to the whole hour. Is it going really slow for you guys today? It is. Speeding for me, so I'm sorry for you. I want you guys to sketch this in your notes. Leave a little space. Sketch this evening. We already sketched it once, but we're going to move on because that's something I want you to do outside of class. You can make your coordinate scale if you want. Negative pi halves to pi halves. But I want to talk a little tiny bit more, and I want to make some observations while we're here before I just send you on the road. So you're going to add the graph of this tonight on your own. Deal?
Yeah.
Okay, and you'll put it like right here. I'm fine with that. It doesn't have to be big. Here's what I really want to notice. Thinking back to sine and cosine yesterday, if I knew the period of a function, like the parent function, it was 2 pi, how did we get the period of the new one? We took 2 pi over what? So we're not looking at this specific one. Just yesterday when we were doing like sines and cosines and stuff, if I wanted to know the period, I said it was 2 pi over b. Now, do we know the period of tangent? It's pi, right? So what do you think we might do if we want to take the period of a new tangent function that's going to look more like that ugly one? It's pi over b instead of 2 pi over b, which is why yesterday when we wrote it for the first time, or the day before, whenever it was, I didn't just write 2 pi over b, I wrote period of sine over b, or period of cosine, or whatever it is that we wrote. I don't remember exactly. Now, the same things are going to happen. What is the period of this one? Pi. Now, if I wanted to make a table for it, how would we determine the jump normally? You take the period and you divide it by, what's pi divided by 4? What did we jump by on this table? Oh my gosh, all the exact same rules that we did yesterday are the exact same here, but instead of using 2 pi, we use pi. So here's my challenge, and I really want to give you a new one. I'm going to hold off 1 second because I can already see some people doing it. Spend a moment, plot this, graph me 2 periods of tangent on your page. I want a graph, and if you've already graphed it and you can't fit it, just let me know and I'll come look at it and we'll talk about it. But I'll give you like 60 seconds right now. Take a moment, or take a minute literally, and give me 2 periods of tangent on your graph of just the parent function. And we'll come back together in just a moment. Oh my gosh. I want you to graph 2 periods. And I did mine very intentionally, so I can't draw 2 full periods because I want to make sure we can see how we remedy this. At the start of class tomorrow, I need you to have this graphed for me. We'll check it really quickly, and then we'll start graphing some more fun ones. There is no additional homework. I'm terribly sorry. All right.